Welcome to Pre-Calculus 12. Today we're going to be starting the unit on trigonometry. And the first thing that we're going to be learning about is something called radians. And a radian is just another way of measuring an angle. So usually we measure angles in degrees. So for example, you could have a 90-degree angle. And we're going to learn that there's another way of measuring that in radians. Just like temperature. You have like degrees Celsius and degrees Fahrenheit. So if you have 32 degrees Fahrenheit, that's the same as 0 degrees Celsius. Just like a 90-degree angle is the same as pi over 2 radians. It's just a conversion factor between one way of measuring an angle and another way. There's actually lots of ways to measure an angle. Engineers use something called gradients. And they say that there's 100 degrees in a 90-degree angle. So in a full circle, they have 400 degrees, 400 gradients. There's other ways of measuring angles as well, but radians tends to be the most useful. So we'll first start with a little review of degrees. You know how many degrees are in one full circle? 360 degrees. Another important thing to know is the formulas for area and circumference. Circumference means the distance around a circle. So if I draw, I have a perfect drawer. Yeah, that's a perfect circle right there. Okay, I know why. My color set on white, that's why. There it is. Okay, so if I draw a circle, the circumference is the distance around that circle. Do you know the formula for circumference? Pi times the diameter. And we can also write that using the radius. The diameter has 2 radii, so this is the same as 2 pi r. And the formula for the area is pi r squared. In calculus, you'll learn how to derive that. And now if we have a radius of 1 centimeter, so we'll just say the radius here is 1 centimeter, then in order to find the circumference, you just put in the number 1 for the radius. So the circumference of a circle with radius 1 is 2 pi centimeters. And that's a perfect answer. You can also write that as an approximate value. So let's see, what is 2 pi approximately? There's my pi button. 2 pi is approximately 6.28. On tests, it's best to keep your answer in a perfect pi form, just like you did with the logs and square roots. Okay, the area of a circle that has a radius of 1 is, 1 squared is still 1, so it's just pi, which is approximately 3.14, 159, 265, 358, 979, 323, 4626, on and on and on. So that's why we don't just write 3.14 because it actually continues forever. So what is a radian? A radian is another unit of angle measure, and in many situations radians are more useful than degrees. Some formulas in mathematics become much more simple when we use radian measure. So how many degrees are there in 1 radian? I'm just going to do a little demonstration for you to show this. So I'll pause the video for a moment. So as you saw in the demonstration, 1 radian is defined as the angle that it takes for the radius to be the same length as the arc that angle subtends. In order to find out what that is on the calculator, all you have to do is go to your mode, right there. Make sure that you're in degree mode instead of radian mode. And then quit back to your main screen. Press the number 1. And then we'll go to the angle menu to find the letter R for radian. So going to the angle menu, So second apse. Second apse. There it is. You go down to the R. That's the radian. And that will give you the value of 1 radian. If you push enter, you'll find out exactly how many degrees 1 radian is. 57.3. So very close to Zach's guess of 55. So 57.3 is this angle here. When the radius is the same as the arc length of a circle. Well, sorry, that should go on the next line. 57.3. What you have to do is you press 1 second apse and then choose number 3. Okay, so we can draw the radian on the circle there. 1 radian is the measure of an angle subtended at the center of a circle by an arc equal in length to the radius of the circle. So we're just going to draw that slightly less than 60-degree triangle right here. So the arc length and the radius are the same length. And that angle is called 1 radian. And that's approximately 57 degrees. So 2 radians would be about 114 degrees. The definition of a radian measure is the length of the arc divided by the length of the radius. So if I'm given any circle, maybe the radius is 2 and the arc length is 5. Okay. Then the length of the arc is 5, the radius is 2, the angle there would be 2.5. This angle would be 2.5 radians. 2.5 of these triangle things. Okay, so it's just another way of measuring angles, just like degrees Celsius and degrees Fahrenheit. Different ways of measuring temperature. Now we can also find a way to convert between degrees and radians without always having to pull out the calculator, just by comparing how much it takes to fill up a whole circle. So in degrees, a whole circle is 360 degrees. Now how many radians are there in a whole circle? Which is equal to?
2 pi.
2 pi. There's 2 pi radians in a whole circle. The reason why is because a radian is the measure of the arc over the radius. So in a whole circle, the arc is the circumference, and the radius is r. And we saw above that circumference is 2 pi r. So that means the number of radians in a whole circle is 2 pi. And that's just a little bit bigger than 6, because we can fit a little bit more than 6 of these triangles in one circle.
What's the stuff going from C over R to 2? Oh, okay.
C is circumference. C equals 2 pi r. So I just wrote 2 pi r instead of C. And we can simplify and solve this for pi. So do you know how many pi radians is equal to? If 360 is 2 pi, how much is just pi? A little bit more. 180. Okay, so 180 degrees is a straight line. 180 degrees is the same thing as pi, because the distance from here to here is pi if the radius is 1. So basically, the radians is giving you the length of the arc if the radius is 1. So it's a really nice way of connecting the size of the angle with the length of the arc on a circle. Just a little notation thing. If you see the degree symbol, that means you're talking about degrees. If you don't see anything, that means you're talking about radians. Mathematicians use radians more than degrees. So if they're writing about an angle, they don't have to put any word afterwards. So you might see 6 radians written as 6 rad. You might see it written as 6 radians, or you might just see it as the number 6. And this one you might see as 240 or 240 degrees, written as a word. So we can change from radians to degrees and degrees to radians just by using the conversion factor. Just like you do in chemistry class, you can make up a unit conversion. So you just take whatever you're starting with, and you're going to multiply it by a conversion factor. So we want to cancel off the radians. So we need radians on the bottom and degrees on top, so that we're left with degrees. And then we look back on the previous page to see 360 degrees is the same as 2 pi. 180 degrees is the same as pi. So 180 degrees over pi radians is just the number 1. They're just multiplying by unit conversion. And then you plug that into your calculator. 6 times 180 over pi. Pi is right above the dividing sign. Is 343 degrees. That makes sense. Because 6 of these triangles fills up how much of the circle? You need 2 pi of them. You need 6.28 to fill up the whole circle. So if you had 6 of them, then you'd be almost at the whole circle. So we're almost at 360 degrees. 240 degrees into radians. We're going to multiply by a conversion factor. We want to cancel out the degrees. So degrees is on the bottom, radians is on the top, and it's always the same conversion factor. In 180 degrees, there are pi radians. So 240 degrees is the same as 4.18 radians, which means 4.18 of these triangles will fill up 240 degrees on a circle. Now, most of the time, we're not going to write radians using decimals. We're actually going to keep them as a perfect answer with pi in the answer. So 270 degrees. In order to change it to radians, we're going to put degrees on the bottom, radians on the top. In 180 degrees, there are pi radians. And now I'm just going to simplify the numbers. So I'll just find out what is 270 divided by 180 as a fraction. 3 over 2. So this is the same as 3 over 2 pi radians. So we don't multiply by pi, and this leaves the answer in a perfect form. Okay, so you try the next one. 315 degrees. Can you find out how many radians that is? Okay, so to change 315 degrees into radians, you multiply by the conversion factor, pi over 180, and then just simplify the numbers. 315 divided by 180, change it to a fraction, is 7 over 4. So this is 7 pi over 4 radians. And you should start to memorize some of these ones. Just get a sense of the difference between radians and degrees. So 360 is all the way around the circle. 180 is pi radians. So how many radians would 90 degrees be? Pi over 2. It's half of 180. $60. 60 is 1/3 of 180. 45. That's half of 90, so over 4. 60 is double 30, so pi over 6. And 1 degree is just pi over 180 radians. Oops. Okay, now this has a practical application. It makes for a really nice formula in determining the length of an arc. So if you're given a circle and you know the radius and you know the angle in radians, then you can find out the arc length. Whee, from here to here. Okay, so A is called the arc length. That's the distance around the outside of the circle. R is the radius. And theta is the angle in radians. This doesn't work in degrees. It only works when you have radians. So you have this really simple formula that all you have to do is take the radius times the arc length. Sorry, radius times the angle equals the arc length. And this just comes from the definition of what an angle in radians is. So if you look on the first page, you'll see that the angle, theta, is the arc length divided by the radius. So we're just basically rearranging that equation from the first page. So if you have a circle that has a radius of 8.2, and you want to find out how much arc length you have if you have 3.5 radians, A equals r theta. The radius is given, the angle is given, so we can just multiply the radius times the angle. So that's 28.7. If we have an angle that's given in degrees, we have to first change it to radians, and then you can use the equation. So I'll show you two ways to do this. First way is using the equation, and the second way I'll call common sense. So in order to use the equation, you need to change the 125 to radians first. So you have to multiply it by the conversion factor. Let's see, what is 125 divided by 180? Make that a fraction. 25 over 36. That's weird. Okay, and then I can plug it into the formula A equals r theta and take the radius times the 25 pi over 36. So I'm just going to times pi times my 8.2 to get a total arc length of 17.89. But that just feels like plug and chug to me. Like I'm just following a series of steps and plugging it in. So I want to actually understand it. So my common sense way is, how much of a circle do I have? So if I have 125 degrees, what fraction of the circle is that? I think I kind of know what that looks like. It's a little bit bigger than 90. A little bit bigger than a 90-degree angle. It kind of looks like this. So if I can figure out what fraction of a circle that is, then the arc length will also be that fraction of the total length. So all I have to do is take my 125 degrees out of the total amount of degrees that I have, which is 360. So 125 out of 360 is 34.7. It's 0.3472, which is about 35% of the circle. Okay, so that angle is 35% of the circle. So that means the length is going to be 35% of the circumference. So I have 35% of circumference. So 35% of 2 pi r. I just take this fraction and times by 2 pi r. I get the same answer. Okay, so that way I don't have to worry about forgetting the formula, because this formula is not given to you on a test. You would have to memorize it. So you can do this using a formula, or you can just use your common sense. And this way I don't have to change to radians. I can work in degrees. To me, this way kind of makes sense. But you can choose whichever method you want to use. So instead of r, I put 8.2, and I get a total of 17.89 centimeters as well. Okay, last page. So we want to find the radius of a circle if we have an arc length of 3 centimeters when we have a 30-degree angle. Okay, so there's a common sense way that you can solve this, or you can solve it by using an equation. So I would like you to go ahead and try whichever way you're the most comfortable with and see if you can figure out what the radius is. So there's 2 ways to do this again. First way you can do it is with the equation, but you have to be careful. When you use A equals r theta, the theta has to be in radians. So first I've got to take my 30 degrees and change it to radians by multiplying by pi over 180. Which, actually, I showed you on the page before that 30 degrees is the same as pi over 6. So I don't actually have to calculate that one. That's pi over 6, because 180 divided by 30 is 6. So the arc length is 3. The angle in radians is pi over 6. So if I solve that, I've got to divide by pi over 6 on both sides. So I'll take 3 divided by pi over 6 for a total of 5.73. Okay, and if I don't remember the equation, then I can use common sense. "30 degrees is how much to the circle?" Like we saw with the warm-up, it's 1/12. With 60 degrees, I can fill up. It takes me 6 slices of 60 degrees to get a whole circle. So it's going to take me 12 slices of 30 degrees to get a whole circle. So this is 1/12 of the circle. So that means that 3 is 1/12 of the circumference. So 3 is 1/12 of 2 pi r. So the radius is 3 times 12 divided by 2 pi. 3 times 12 divided by 2 pi is 5.73. Okay, so that's just a common sense way to find the radius instead of using the formula. Then you don't have to worry about changing your radians. Yes? So now a question a little bit more challenging. We're given two of the angles here, ABC and BAC. They're both pi over 6 radians. We want to find out what is the length of the radius if this distance here is 15.2 centimeters. So we're given the arc length. We don't know the angle, and we don't know the radius. So somehow we have to use the fact that both of these angles are pi over 6 to be able to find this middle angle here. Do you know how many degrees pi over 6 is? This is the same one from the last question, 30. So that means we've got two 30-degree angles in this triangle. So what's the last angle? 60? 120. All together in a triangle, there's 180. So there's 120 degrees in that middle angle. 120 degrees is 2 60s. I know that 60 is pi over 3, so 120 is 2 pi over 3. And you can check that by multiplying by pi over 180. So let's do that. 120 divided by 180 is 2/3. 2/3 pi. So the angle is 2/3 pi. So now using the formula, I can determine the radius. 2 pi over 3, just by dividing both sides by 2 pi over 3. Just make sure that you put that number in brackets when you're dividing by a complex fraction. And you get a radius of 7.3 centimeters. Okay, or you could use the fact that 120 degrees is 1/3 of a circle. So 15.2 is 1/3 of the circumference. And you can use that to find the radius as well. And now a provincial exam question. See if you could determine what the radius, what the arc length of this circle is. So because the sector angle is already given in radians, you don't have to exchange from radians to degrees. We can just directly apply the A equals R theta formula to multiply the radius times the angle to find the arc length of 20 centimeters. So the answer is D. Your homework for today is page 214, numbers 5 to 8, odd letters, and 9 to 16.